Alright, welcome to today's video where we'll continue with section 4.4. The first thing that I want to do is just review something from last night. Remember the all students take calculus, where all of the trig functions are positive in the first quadrant, the sine is positive in the second quadrant, the tangent is positive in the third quadrant, and the cosine is positive in the fourth quadrant. And remember some of these problems, like for example, if I gave you the tangent of theta is equal to negative 2/3 and the cosine is positive. Well, the cosine is positive in the first and the fourth, and the tangent is negative in the second and the fourth. So we know that this picture has to be drawn in the fourth quadrant. With our reference angle right here. And remember, since tangent is y over x, that we have negative 2 and 3. And then to find the cosine, we need to find the r value. R is the square root of 3 squared plus negative 2 squared. So it's 9 plus 4, which is 13. So it's the square root of 13. So the cosine, remember, that's x over r, which is 3 over the square root of 13, which equals 3 square root 13 over 13 when you rationalize. For the cosecant, remember the cosecant is the reciprocal of the sine, which means you would have r over y instead of y over r. So the r value is the square root of 13, the y value is negative 2. And that is your answer. So that's a quick review of what we did yesterday. Now today, we're going to focus more on the reference angle. And remember, the definition of a reference angle is basically for any angle in standard position. So let's say you had an angle in standard position. Like here, there's our angle in standard position, and it lies in a quadrant. Its reference angle is the positive acute angle formed by the terminal side and the x-axis. So notice here's theta, we rotate it. Here's our terminal side. Alright, the positive acute angle, which is right here, that's formed by the terminal side and the x-axis, is the reference angle. Alright, it's not the y-axis. Alright, it's not this one up here, which a lot of people will put. It's not this one. This is the reference angle right here, between the terminal side and the x-axis, not the y-axis. Alright, so if we want to find some angles, some reference angles, excuse me, for certain angles, here's what we will do. So for example, 210 degrees. If I draw 210 degrees, 210 degrees, remember, is in the third quadrant. Because remember, this is 180, 0, 90, 270, 360. So 210 would be somewhere in the third quadrant. Now, our reference angle, remember, is between the terminal side and the x-axis. So this would be our reference angle here. And our reference angle for 210, we take 210 and we would subtract 180. So 210 minus 180 equals 30 degrees. And that is our reference angle for a 210 degree angle. That would be this angle right in here. For 7 pi over 4, you have a couple options here. Number one, you can use the fact that in radians, this is pi over 2, this is pi, 3 pi over 2, and 2 pi. And so 7 pi over 4 would be basically would be rotated if you look, 7 pi over 4 would basically be rotated all the way around to the fourth quadrant. And so this would be the reference angle right here, and since this is 2 pi, you would take, for part B, you would take 2 pi and subtract 7 pi over 4. So remember, when you get a common denominator, you multiply by 4. So you get 8 pi over 4 minus 7 pi over 4, which would be pi over 4. Or you could change it from radians to degrees. 7 pi over 4 times 180 over pi. 4 goes into that 45 times. The pi's cancel out. 7 times 45 is 315. And then you could subtract from 360 equals 45 degrees. And then you change that back into radians and you still get pi over 4. For negative 240 degrees, let's move over here. So if we want to find the reference angle for negative 240 degrees, remember, negative, you're here, but then you go this way. So 90, 180, 240 would end up here. And remember, so this is negative 240 degrees. The reference angle is between the terminal side and the x, so it's this space here. Well, if this is negative 180, think about it, 240 minus 180, this reference angle would be 60 degrees. And so our reference angle here is 60 degrees. And our reference angles are always positive. So even though the angle is negative, in the negative direction, our reference angle would still be positive. So next, finding a reference angle for angles greater than 360 or 2 pi. Well, if I want to do like 580 degrees, what I would want to do is basically find a coterminal angle less than 360 or 2 pi. So if you wondered why we did that in the last section, this is why. Because we're going to use it here to find a reference angle. So we want to find a coterminal angle less than 360 or 2 pi. So for part A, 580 minus 360 would give me 220. Alright, then I'm going to find the reference angle for that coterminal angle. And I'm abbreviating here. So finding the reference angle for 220 degrees, is in the third quadrant. And remember, this little space would be the reference angle, so 220 minus 180 would give you 40 degrees. And that would be our reference angle for part A. For part B, if it's in radians, once again, you can change it to degrees, or remember, you subtract 2 pi to find the coterminal angle. Well, 2 pi times 3 is 6 pi over 3. That's 2 pi over 3. So basically, to find a reference angle for 2 pi over 3, remember, you have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So when we rotate, 2 pi over 3 is bigger than pi over 2, but it's not bigger than pi. So here's 2 pi over 3 rotation, and here's our reference angle. So basically we would subtract pi from 2 pi over 3, and notice, getting a common denominator, makes that 3 pi over 3. So basically the reference angle there is pi over 3. Now, if you wanted to, though, you could change it to degrees and do it that way, and then change your answer back to radians, and that is fine. That's fine. That's also an option. Alright, this concludes our short video for today on how to find reference angles. This stuff is important because we're going to build up to finding trigonometric values. Any questions, please feel free to ask in class, and also have a good weekend. Bye-bye.